Hey guys, it's Nicole,
And Kavisha,
and we're going to be reminding you about Unit 3.
aka modeling distributions of data.
So, what is a z-score, Kavisha?
Oh, well, z-scores are basically standardized values, and remember, they don't have any units. They're used to compare numbers of different scales or from different populations because, again, they're standardized values and they don't have units. So they're easier to compare.
Do you recall what a density curve is? Well, if not, a density curve describes the overall pattern of the distribution. It includes that it is always on / above the horizontal axis, and it always has an area of 1 below it. The pictures below show the different areas where the mean / median are located when there's different shapes of the graph. For the graph on the left side, the mean and the median are in the same location, and that shows an approximately normal graph or a graph that's symmetric. The second graph describes where the median and mean are located when the graph is skewed right, and the graph on the right hand side describes where the mean and median are when the graph is skewed left. So the green signifies where the mean is, while the red signifies where the median is. Next, we have the empirical rule, aka the 68, 95, 99.7 rule.
Okay, so basically, there was this king who was really mean and he ruled 68 territories. And out of the 68 territories, he ruled 95 people in all. And out of those 95 people, 99.7% of them basically hated him because, he was like really mean. The whole point of our story was basically to help you remember the 68, 99, 95, 99.7 rule, because I know the numbers can be hard to remember sometimes. But just a review, if you go one standard deviation out of a normal distribution, 68% of the observations will fall within one standard deviation, 95% will fall in two standard deviations, and 99.7% of the observations will fall within three standard deviations. And then the rest are just like here.
So before we mention the z-scores, and the z-scores are the standardized scores of, and has a standard normal distribution. So basically the standard normal distribution is when the mean is 0 and the standard deviation is 1. And we forgot to say this, but usually it's very rare for the observations to be more than 3 standard deviations from the mean in a distribution that is approximately normal.
That also applies to the empirical rule. So, like, most of the observations won't fall outside of 3 standard deviations.
So for standard normal distribution, when we're writing the notation, it will look something like this. So for example, for our graph that we have on the board, the notation would be right here.
So, in case you forget your calculator on the AP test, which you really shouldn't, by the way, here's how to use the z-table to find the probability when you have a standard normal curve.
So this is just a small portion of the z-table. The columns and rows help us show our z-score that we have.
You can also use the z-table if you're given the probability or the area, and if you want to find the z-score corresponding to that, you can just take the area from the inside and you just take that number and you correspond it to the outside number. So if you had a probability or an area of 0.8186, it corresponds to 0.91. So some helpful notes and tips for when you're dealing with problems that ask for like a probability or whatever, is to like draw out the distribution with the shading so you know which way to shade. Like if the probability asks for greater than, shade here, less than, shade there. And also pay attention to what's given, like whether the area is given or a z-score is given, or if the x is given.
Also, just some reminders again. To check normality, you can use 4 different graphs to check if it's there. There's histograms where the bar graphs have no spaces in between them, and we also have box plots, and there's also stem and leaf plots, as well as normal probability plots, or also known as normal quartile plots.
So basically for the first 3, the histogram, the box plot, and the stem and leaf plot, if they're approximately like normally distributed, where the middle has like the most and the ends have like the least.
Shows symmetry.
Yeah.
Yeah.
For these 3. For box plots, it's a little different because you just have to make sure the box is like pretty even, and then like the ends are pretty even. And for this one too, it's like
it shows a sort of mountain single peak shape.
Yeah, bell curve. And then for a normal probability plot, it has to be roughly linear. Usually it won't be like this linear, but it'll be like roughly linear.
This
is the end of our presentation. Thank you.